This video will walk you through simple regression analysis in Excel. So I'm doing my first of my Chapter 14 review questions, and this is using stock data. And I'm asked to develop a regression equation using fair value to predict stock price. So here what I want to do is see how fair value X can be used to predict stock price Y. So my independent variable is going to be fair value, and my dependent variable, Y, is going to be stock price. And I'm going to answer these 6 questions here. So the first thing I'm going to do is go into data, data analysis, and regression. Scroll here. Click OK. My Y variable is my share price. That is my dependent variable, so I believe fair value can be used to predict stock price. So stock price is my dependent variable, my Y variable. My X variable is the variable that I use to make that prediction, so that is my fair value there. I have labels in my first row, so I'm going to check that off. I want a 95% confidence interval. It'll give me that default, but I'll select it anyway. And I would like to put my output on this sheet. So let me click in here and find an option where to put it. That looks good. So I'll click OK. All right, now let's open this up a little. Oh, doesn't need to be open that much, but that's okay. So my first question here, state the regression equation. I find that information by looking here at this relationship with the coefficients. So this says stock price, which is my Y, is equal to negative 2.987 plus 0.911 fair value. Next, it asks me to interpret my beta coefficient. So the only beta coefficients I have here are beta 0 and beta 1. There really isn't much of an interpretation for beta 0. That tells you the y-intercepts. Remember, this is basically just an application of algebra y equals mx plus b, where b was your y-intercept. So this gives you the value of the stock price when the fair value is equal to 0. So it really does not have an actual practical interpretation. But my beta fair value does. My beta fair value is 0.911. So since both of my units are in dollars, I would say for every $1 increase in fair value, stock price is predicted to increase by 91 cents, holding all other variables constant or ceteris paribus. Now, here that's kind of irrelevant because there's only one variable, one independent variable that I'm talking about here. But the general interpretation is for every 1 unit increase in X, Y will increase by the coefficient of that X variable. So for every 1 unit increase in fair value, here the units are $1, so for every $1 increase in fair value, stock price, Y, is predicted to increase by this coefficient. So again, since this is in dollars, for every $1 increase in fair value, stock price is expected to increase by 91 cents. Next, I can go up here, develop or interpret the 95% confidence interval for my beta estimates. Okay, so I can go over in this range, and I can see my upper and lower. Now, if you notice, if I scroll over, too far. If I scroll over, it repeats upper and lower 95% twice, just to, clean up the appearance. I tend to take that off. Okay, so the only one I really need to interpret is my beta of fair value. So I have 0.71 and 1.11. That's my 95% confidence interval estimate for the impact of my X on my Y. So in this case, I am 95% confident that for every $1 increase in fair value, stock price is expected to increase by between my lower and my upper. So by between 71 cents and $1.11. How much of the variation in the dependent variable is explained by the regression? To find that answer, I look at the R-squared. And this says roughly 77% of the variation in Y is explained by my regression. In this case, is explained by X. So, roughly 77% of the variation in stock price is explained by fair value. Now, in general, we say the higher the R-squared, the better, but that's something that you really need to take with a grain of salt. We'll talk about when we get to the next chapter where we do multiple regression, we'll see that we can use this adjusted R-squared, because as you increase the number of independent variables, R-squared is artificially increased as well. But it's also something that, so higher is better, but you also have to look at it in terms of what you generally tend to see within that industry. So in some industries or in some cases, a 30% R-squared could actually be really good. That could have really good predictive power, versus in others you're looking for, if it's less than 75%, it's probably useless. So in general, the basic rule is the higher the better, but then you need to be familiar with your area in which you're investigating in order to know, how good of an R-squared you really should be looking for. All right, does your independent variable have a statistically significant impact on your dependent variable, using both the T and F tests? So what that is asking is a particular beta equal to 0, or is it not equal to 0? So is beta fair value equal to 0? That would be my HO. I would look at my p-value there, and that is obviously less than 0, so it's definitely less than 0.05. And therefore, I would reject HO and say I am 95% confident that fair value does have a statistically significant impact on stock price. And that is the t-test version, and that can be done for each independent variable. In this case, there's only one, just fair value. The f-test, on the other hand, now note here the f-test has the same p-value. We look at significance of f, that means p-value of f. F tests whether all of the independent variables together have any impact on the dependent variable. So HO is all of the independent variables together have an impact on the dependent variable, and HA is at least one of them does not. And here, do not, and then at least one of them does. So here we are going to reject HO, and again, we're going to say that fair value does have a statistically significant impact on share price. Question 6 asks to conduct a hypothesis test to determine if the independent variable has a positive or negative impact on the dependent variable. Now notice I have incorporated in here, I copied and pasted in this hypothesis testing area. Okay, so I need to know my hypothesized value, my t-stat, and then my p-value, upper, lower, or two-tail. So if I just want to know, does the independent variable have a positive or negative impact, then my hypothesized value would be 0. How do I calculate my t-stat? Now, in order to get around potential issues with using the t-distribution, the simplest way is just to use the absolute value. So the absolute value of my coefficient minus its hypothesized value divided by the standard error of that coefficient, that'll give me my t-statistic. Now I need to calculate the p-value. So t-dist x is the t-statistic I calculated. Degrees of freedom is n minus 1. And tails is true. So that's going to give me my lower. 1 minus that gives me my upper, and 2 times the minimum of that gives me my 2 tail. So I can use this hypothesis testing quadrant to test a variety of different hypotheses. If I wanted to know, is there any impact, does X have any impact on Y, I can look at my p-value 2 tail. Now, that I don't really necessarily need to check because that p-value was already, or that hypothesis was already tested down here in this fair value, in this p-value calculation here. So one of the things I can do to confirm that I have my hypothesis testing set up is confirm that this p-value 2 tail gives me the same conclusion. And yes, here in fact it does. The next thing I can look at is which test do I want to perform. Now here these were just the generic list of questions that could be asked about simple or multiple regression. So here it's a question of whether I want to test for a positive or negative impact. If I want to test, does my independent variable have a negative impact, I would look at my p-value upper. And if I want to test, does it have a positive impact, I would look at my p-value lower. So remember, in hypothesis testing, everything is backwardsville. Everything is the opposite of what you expect. So if you want to test, does your independent variable have a positive impact, you look at your p-value lower. And if you want to know, does it have a negative impact, you look at your p-value upper. So let's conduct a hypothesis test to determine if fair value has a statistically significant positive impact on stock price. So I'm going to look at my p-value lower. I would reject HO. So remember the way hypothesis testing works, I want to know, does it have a positive impact, which means I test that it has a negative impact. So I'm looking at my p-value lower. So I'm rejecting the negative impact, which is telling me that yes, it does in fact have a positive impact. So HO here is beta fair value is less than 0, and HA, beta fair value is greater than 0, greater than or equal to 0. So I would reject HO, so I am 95% confident that fair value does have a statistically significant positive impact on share price.